Okay, today we're going to learn how to multiply a matrix, which is a question that crops up, I would say maybe one in every two, one in every three, approximately, ACT papers. It's usually towards the end of the paper, in the last 30, maybe last 20 questions. Often you're not required to multiply the full matrix, but you just have to find one of the entries or something, because it's actually quite a long process, so they don't usually ask you to do the full thing. I'm going to show you how to do the whole thing, and you should practice it because it's a difficult method to remember. Okay, so here goes. Let's say we have the matrix A, which is 3, 2, 1, 4, I don't know, 0, 7. And we have the matrix B, which is going to be 6, 8, 1, 2, -1, 3. Could be whatever you want. Okay. This matrix A has 2 rows and 3 columns, so we'd call it a 2 by 3 matrix. And these are that's what's known as the dimensions of the matrix. Matrix B has the opposite. It has 3 rows and 2 columns, so we'd call this a 3 by 2 matrix. So let's say we want to find the matrix product AB. So first of all, we need to check, using the dimensions rule, whether we can actually even find this product. So if we want to do A times B, we'd be multiplying a 2 by 3 matrix with a 3 by 2 matrix. If these two numbers are the same, then you're good to go. So call them like the inner dimensions. So if the number of columns in your first matrix is the same as the number of rows in your second matrix, then you can go ahead and multiply them. Otherwise, we would say the product AB does not exist. I'll show you an example of that later. You also know what the resulting dimensions will be from the two numbers that are left. So when we multiply the matrix AB, we get a 2 by 2 matrix. So I'm going to draw a line to represent each entry. It just makes it a little bit easier to follow. Okay, so here goes. So the first entry, I think about the position of the entry in the matrix, and that tells me how I'm going to calculate it. So this entry right here is in the first row and the first column. So I'm going to get that by multiplying the first row of A by the first column of B. So I need to do 3 times 6, and I'm going to struggle to fit this all in, 3 times 6 plus 2 times 1 plus 1 times -1. Okay, and I'll simplify this all in a second. Okay, this entry right here is in the first row and the second column. So I'm going to get it by multiplying the first row by the second column. So I'm going to do 3 8s plus 2 2s plus 1 times 3. Okay, this entry, you probably know the drill by now, is in the second row and the first column. So I'm going to multiply the second row by the first column. So 4 6s plus 0 times 1, I'm not going to write that to save space, plus 7 times -1. And this entry is in the second row, second column, so I'm going to multiply the second row by the second column. So 4 8s by 0 times 2, which is 0, so I'm not going to write that, plus 7 times 3. Okay, now that I've got all of that, I should just go ahead and simplify it. So 3 6s is 18, 2 1s makes 20, plus -1 gives us 19. This entry, 3 8s are 24, 2 2s are 28, that makes 31 in total. 4 6s is 24, plus -7 is 17, 4 8s is 32, plus 21 is 53. Okay, so that is our matrix product AB. This is a process that you can do on your graphing calculator. If you have something like the TI-83, TI-84, that series of calculators, then you can do this using that. I suggest you use the instruction manual to figure out how to put a matrix into that. Sometimes it's easier to know how to do them by hand though, and especially with the types of questions they ask you on the ACT, it's not always to multiply the whole matrix, it's just maybe to find one entry in this. So let's say they were asking you for this entry, so they might lay out the question where they give you like 19, 31, x, and 53. Oops, it's not a very good x. They would say AB equals this, find x, and then you just know that because this entry is in the second row, first column, you're just going to multiply the second row by the first column to give you 17, and that's actually quite a quick procedure. But if you're going to plug that all into your graphing calculator, it's going to take you quite a long time. So if you're looking to save time on the ACT math section, I would learn how to do this manually as well as in your graphing calculator if you have one. If you don't have one, you're not really at a disadvantage. That aside, let's do the matrix product BA and see how that's different. So BA is a 3 by B is a 3 by 2 matrix. We're going to multiply it by A, which is a 2 by 3 matrix. Okay, this still works because our inner dimensions are still the same. Our outer dimensions happen to be the same, but they don't have to be. If A was a 2 by 4 matrix, that would be the same as this, and it would still work. BA, however, is going to be a 3 by 3 matrix. So I'm going to try and draw it a little bigger this time. So this is how it will look. I like to draw out the spots where the entries are going to go first because it helps you to keep track of what you're doing. Okay, this entry is in the first row and the first column. So we're going to multiply it, and remember we're doing BA, so it's got to be this way around. First row by first column. So we're doing 3 6s plus 4 8s. And this time I only have 2 sums in each thing just because of the way the matrix multiplication is working itself out. Okay, this entry is in the first row, second column. So I'm going to multiply the first row of B by the second column of A. So first row of B, 2 6s plus 0 8s. I'm not going to write the 0 times 8 because it's just 0. This entry is in the first row, third column. So I'm going to multiply the first row by the third column. So 6 1s plus 7 8s. So that's your answer. Sometimes on the ACT, they ask you to do a matrix multiplication, but only one of the answer options they give you has the correct dimensions. So you don't actually have to do any multiplication, you just have to work out what the dimensions of your product should be. Lastly, this is an interesting property of matrix multiplication. Since we've done AB and BA, we've noticed, obviously, that the product AB does not equal the product BA. Now that's odd because normally when we multiply stuff, it's the same either way around. 3 times 5 is the same as 5 times 3. That property is known as the property of commutativity, which means A times B equals B times A. Let's not use A and B because that's kind of confusing. Let's just say 2 times 3 equals 3 times 2. So multiplication is normally commutative. Matrix multiplication is not commutative. So we would say the fact that AB does not equal BA means that it's not commutative. Another example of an operation that's not commutative is subtraction. 3 minus 2 is not the same as 2 minus 3. So that is not commutative. Okay, that's pretty much all you need to know about matrix multiplication for the ACT. Hope that's helpful to you. Remember to practice this method.